Have you ever wondered the physics on how a cloud moves as it is being pulled by a carabao? How a man moves a cart in a store? Or how a weightlifter lifts weight on top of his head? How do these things become possible? Let us all discover the answers as we explore work, energy, and power. Let's go!
Did you know that when you applied force to a box by pushing it, the applied force causes displacement on that object is what we call work? In physics, work is the action done on an object that displaces the object in the direction of the applied force. Work done can be calculated by multiplying the magnitude of the force and displacement of an object. Its SI unit is joules.
Work is said to be done only when displacement occurs. If you push a brake wall with the same amount of force for the same amount of time as the box, you may get very tired. But technically, you've done zero work or no work at all. Work is positive if the applied force is the same direction as the displacement, and work is negative if the applied force is the direction opposite to the object motion.
Remember, in order to apply force and do work, we need the ability to perform work is known as energy. There are all different kinds of energy, but now we mainly be talking about two of them, the kinetic and potential energy. Kinetic energy is energy in motion. When the box is resting in the ground, we'd say that it had no kinetic energy. But once you applied force and it started moving, it did have kinetic energy. Kinetic energy of an object is equal to half of its mass times its velocity squared.
The second type of energy is an energy that could be used to do work. It is an energy at rest, and that is a potential energy. One common type of potential energy is that the gravitational potential energy. It comes from the fact that gravity exists. If I hold this book a meter above the ground, we can say that it has a gravitational potential energy because if I let it go, the gravity is going to do work on the book. When the gravity exerted a force on the book that move it to the ground, and once it hits the ground, the gravitational potential energy becomes zero. Since the gravitational potential energy becomes zero, it can't work on it anymore. We can calculate the gravitational potential energy using this formula by multiplying the mass of the book times the constant for gravity times the height of the book.
Another type of potential energy is elastic potential energy or energy stored in elastic materials. The greater the displacement of an elastic material from its resting position, the greater the energy stored in the material. Elastic potential energy can be calculated using the formula 1/2 spring constant times distance squared.
Power is the rate at which work is done. It is calculated as the amount of work done divided by the time. Power is measured in watts, where 1 watt is equals to 1 joule per second.
Power is directly proportional to the amount of work done and inversely proportional to the time it takes to do work. In short, in order to do work over a short period of time, greater amount of power must be exerted.
Work, energy, and power are all connected.
Although it may not be obvious, there's a direct connection between your energy use and the environment. When you consume less power, you reduce the amount of toxic fumes released by power plants, conserve the Earth's natural resources, and protects ecosystem from destruction. Renewable energy sources such as wind, hydroelectric power, solar, and geothermal energy are generally far more sustainable than fossil fuel sources. Let us all save the environment and live in a green lifestyle.